Well, thanks for having me in today. For those of you that don't know me, my name is Pete MacPherson. I'm the territory manager for flight in the upper Midwest. I have 12 and a half states that I cover. I live here in Minnesota up in the Park Rapids area, and have been up in that area for about 11 years. And just one thing that I want to point out initially is that a lot of the folks in here probably don't recognize this name, Xylem, up in the right corner here on my slide. But that is our parent company at Flight now. ITT, a lot of you probably remember that ITT Flight was kind of our slogan name. And last October, the company ITT actually split into 3 different entities. And their Water Solutions Group, which is us, Flight is part of that, is now under a corporation called Xylem. So it was a newly formed corporation last October, and just to clear up any confusion as to what that name actually means, is that 4 major brands under the Xylem name, of which Flight is one of those major brands, are working under that parent company. So the management stayed the same. The employee base pretty much stayed the same. The managers across the country stayed the same for Flight. So not a lot changed other than, you know, one of those big corporate transactions happened and we have a new name. But what I'm here to talk to you today about is really some innovative work that Flight has done in R&D for pumping, specifically wastewater. And to talk and talk about the whole concept of the green movement, to talk about energy efficiency and what that means to you as operations personnel at your communities, and what kind of savings that and payback that you can get back to help pay back labor charges for certain things in your community, to pay back electrical costs from the savings that you see in electrical costs. So what Flight has developed is a concept called Experience. We've had a wet end in our pumps since 1999 called the N technology, which has developed a little more since then. But we've guaranteed at Flight a 25% energy savings over the years in that decade with that type of wet end in the pump. Along with that, we've added high efficiency motors to that as well, which can give about an extra 3 to 4% of efficiency to a unit as it runs. And we run this concept all the way from our smallest pumps for typical domestic and industrial wastewater from 3 horsepower all the way up to 105 horsepower to our, what we call our 3301 model. So we have the ability to do these things. And then thirdly, what we focus on is what we call a smart run controller. And that's primarily the focus of my talk today, is to talk about a smart run controller and how it can simplify your panels, simplify your maintenance, and also give you some pretty significant energy savings out at your sites. And the thing that I want you all to remember is, I was in operations for a long time for a community, and as long as the stations were running and we did our day-to-day rounds and we checked things on the weekends and we were pushing water, we didn't think much about some of the other things that went along with it. But we all know as operations personnel that the #1 line item in our budgets, the biggest cost that we have at plants, at pump stations, all those things that we run where we're running rotating equipment, is electricity. So in our world, we've always focused on pretty much large pump stations, trying to get big bang for the buck. Where can we get some efficiency out of these big pumps? But in all reality, if you're a community that's running multiple pump stations and you can compound that savings over 5, 7, 10, 14 pump stations, however many you're running, that money can be pretty significant. And the fact that with this type of technology, passing today's modern trash through your pump, sustaining efficiency in the wet end, combining it with the high efficiency motor, and then using the Smart Run controller, Flight has found a way in those pump sizes from 3 to 105 to save 50% in electricity at your pump station in specific energy. And I want to talk about that here today. So when we look at those things, what we're meaning by this is we looked at our customers, excuse me, we did some surveys with a lot of our customers all over the world actually, and asked them what was most important to them. And the thing that we came up with were these three things. They want reliability in their equipment, they want it efficient, and they want simplicity. They don't want, what we found is that the technology is moving so fast, but yet a lot of the operations personnel didn't feel comfortable with all the bells and whistles, so they wanted it simple. So we took that into account and developed these very things and did these intelligent controls that are very simplistic for your system. So that's the problem. Clogging. We have that problem all over with today's modern trash, with the wet tex items, the wipes, all these things that are being flushed down into the system. That's what's happening to our pumps. So I don't know if any of you passed through our booth yesterday, but here's an example of the wet end of the end impeller and what that can really do with those kinds of materials. So these were R&D tests in the Flight factory in Sweden, showing wet tex items, towels, bottles, things of that nature going through this pump. That pump there, that test is being done on a model 3127, which is roughly a 10 horsepower pump. So that just gives you an idea of the types of materials that can pass. So what does that really mean? When you couple this with the controller, it actually means that we can pass those materials through the pump, we can sustain efficiency over time, and when you look at standard channel impellers, which Flight developed for a long, long time, and many of the competitors out there do, there was a soft clogging phenomenon, meaning that the stringy materials, some of these rags in the system, the wet tex items that we're seeing in the wastewater stream, would ball up on each other and give partial clogs in the pump itself. So you might still be pumping, but and burning electricity the same amount, but you're not getting as much flow. Now, as an operator, if you don't have some sort of system or flow meter on your station, you're not necessarily going to know that. So sustaining efficiency with this wet end is a big part of the savings that you can have. So what does it mean? We've got a back swept leading edge on that impeller. It's open, it's not double shrouded or closed like you see with a channel impeller. In this area here we have a relief groove and this guide pin that you saw in the video that actually guides the material into the pump and passes it through. The solids get trapped inside that relief groove and pass through the wet end of the pump, sustaining that efficiency, not allowing any soft clogging. And once a soft clog phenomenon gets bigger, you can actually clog the pump entirely, and that means labor calls. That means going out to the site, pulling the pump, extracting the material out of the pump, and then moving on. Modular system where we can do the standard end, and then we can put a different insert ring inside that volute as well to get a chopper pump as well. So it's a modular system. So for this kind of application, institutions, prisons, nursing homes, things of that nature where we tend to have some odd things that might get into the stream that we normally don't see in standard domestic wastewater. Another feature that we've done as part of this system is we put what we call an adaptive end impeller in the wet end, and that's an actual in our 3s, 5s, 7.5, and 10 horsepower in those smaller units. This actually has the ability when a large piece of trash comes into the pump, modern trash, this has the ability to raise up to 15 millimeters depending on the model. It will actually pass that material through the pump, helping those smaller horsepower pumps pass larger material through them. It also helps with savings on seals, bearings, because it absorbs shock better. And when those big materials come in, it actually raises that impeller up, shortening your shaft overhang. So anytime you have a piece of rotating equipment and you're spinning it, and a piece of material comes into that pump and hits it, it creates shock. By moving that impeller up a little bit, it shortens that shaft overhang length, saving and lengthening the time of your seals and bearings and wear and tear on those. These were some of the tests that were done, talking about channel impeller efficiency loss over time and that soft clogging phenomenon that you see. That's been done, and it's been done in all kinds of pumps in R&D, and that's the kind of efficiency loss that we see in the end. None. It just sustains over time. So with that said, I'm going to jump to the controller portion. So these are the risks that we run when we actually don't have with inferior pump control. These are some of the things that we see in system. We get sedimentation, clogging, which we've talked about, build up of floating debris in your sump, decreased equipment life, which we've touched on a little bit, and very high energy consumption. And these were all the things that we were trying to solve with our Smart Run controller that's been developed. So this is what it looks like, and it's as simple as that. And it can be as advanced as you want. It has all the functionality to go into a full PLC, SCADA-based system where you're doing all kinds of monitoring. It's got the ability to talk Modbus, and you can pull signals out of it and pull it into any kind of system that you're running now. But basically what this unit is as simple as that. You can have it as simple as this controller and this controller, which work independently of one another. And it's a new concept in the wastewater business. We are very used to running our pump stations in an alternation sequence, okay? This is a new concept in which each one of these controllers is assigned to one pump. And each pump basically, to make it simplistic, is to say that it's got its own brain. The only thing that it shares is a high-level float for a high-level emergency, and a transducer signal that they both share where the level is in the station. Other than that, they're independent on their starts and stops and all that with the set points. And I'll talk about that a little more because everybody is looking at me with this blank stare. But what does that really mean? If you look at this, this would be a panel. You have your incoming power, a breaker. You can make it as simple as running your power into the top of this unit in each instance, and then run your power cable up from your pump using the end technology in here, setting a transducer and a high-level float at somewhere in your basin, and you're done. So you get your panel. This will run a station. So So you eliminate alternators, you eliminate pump controllers, you eliminate a lot of components within your system. The nice thing about these too is in our pumps, obviously we have a float leakage sensor, and with that we also have an overheat or overtemp sensors in the pumps, and this unit will accept all of that. So all of the functionality of what we call a flight mini-cast, which is a plug-in unit to monitor that, is all done within these units. So that gets eliminated as well. So it's that simple. So what is it designed for? The Smart Run controller is designed for duplex stations only. If we get into triplex, quadplex, bigger stations, then we have to go to more advanced type controls. But this is designed for the typical duplex station from that 3 to 105 horsepower inside. So what kind of functions does this have? It's got an energy minimizer on it, and we're going to get into that a little bit deeper. Pump cleaning functionality. What does that really mean? It means that if it's sensed that that pump is going to clog at all, it will literally take that pump, and all of this functionality, operators can decide if they want it or they don't as well. So it's completely programmable, but it has pump cleaning functionality where it'll take that pump, if it's starting to send an amperage change from a clog, we'll literally stop that pump, run it in reverse for less than 1 second, clear the clog, and start rotating in the right direction again. It has that built right into it. It has sump cleaning function. We learned this from our mining experience at Flight, where we did a lot of sumps and mines, underground mines, is that we needed to get the pumps down to a snore condition once in a while to keep those sumps clean. It's no different in the wastewater stream. It's no different than you going out to your pump station, putting your station in hand, running it down to that snore condition, and what that means is right where that pump breaks suction is that snore condition, and what this unit will do will sense an amperage change when it actually hits snore, and before it gets to a point where it can airlock, it will shut it down, but it actually helps keep your sump clean. It'll take it down on however many cycles you want to program. You want it done once a day, you want it done once a week, it's got that sump cleaning functionality in it, helping keep settleable solids, greases, and things like that cleaner in your sump. Pipe cleaning, it's got pipe cleaning functionality. So really, what does this unit do? In the scheme of things, what we're doing is we're taking your pump, we're picking a selection in our pump line, and we're optimizing the speed of that unit to the best efficiency point on the curve of that pump to maximize its best efficiency point in your system. So what that really means is anytime we slow a pump down, the concern becomes, what's my scouring velocity? Am I keeping my 2.5 feet per second to keep my materials moving through my force main? That's always a concern anytime you slow a pump down, and that's a concern that we always get asked. Well, again, a programmable function is pipe cleaning. So we will take that pump and run it to 60 hertz at least once every 24 hours or on every start, if you so desire, to clean that pipe, get it up to 60 hertz, full speed, 100% speed, and then we slow it back down to that point where you're actually maximizing your specific energy in that station. And that's where that energy efficiency and that cost savings is coming to you over time throughout a year. Now, one of the things that we can do at Flight, and with Electric Pump, the company that represents us, obviously, you know they represent us here in Minnesota and the Dakotas, is that the guys at Electric Pump have the ability to come to your sites and use what we call an energy savings calculator to come out and evaluate your current sites. And what they do is they look at your pump station, they determine how many hours that pump station is running in a year, they look at your power bill and determine what you're paying in kilowatt hour for power, They look at what kind of impeller you currently have in that system now, and they plug all this information into this energy savings calculator, and it basically creates a pie chart. And it will tell you that with the functionality of a smart run controller and hydraulics, with a high efficiency motor, all three of those things, or mix and match however you would like, what kind of energy savings you can see at that specific installation with this equipment. So you would have an idea, and I just plugged one in today as I was working this morning. I plugged one in, a 60 horsepower unit running 1,500 hours a year at 7.5 cents per kilowatt, going from a channel impeller to an N impeller, and I calculated a $3,000 savings per year per pump at that horsepower. So it can be significant. And if you're running multiple pump stations throughout your community, that's the kind of savings compounded. You can see a lot of savings in the fact that you can get that payback on equipment quite quickly. It also has pump and drive protection, which we talked about. Our overtemp and our leakage is built into the unit. It has a soft start and stop. So we can ramp the unit up slowly like you would with a variable frequency drive. You can actually slow the pump down slowly so you're not getting water hammered, things like that in your system. So that's built-in functionality into this unit. We'll get into the alternation without communication, and it's very simplistic to use. Easy menus. Basically, it's what we call plug and play, like you have now with a lot of our computers and a lot of our electronics in the world that we live in today. It's a plug and play unit where it comes pre-programmed from the factory. It gets installed, you power it up, and if you want it to be as simple as pushing the start button and activating your station without doing anything, all that functionality and these wastewater algorithms are all going to be written into the program, and you're going to have all that functionality right away. You don't have to have anybody come out and program it. You don't have to pay high dollar amounts of labor to have somebody come out and do those sorts of things. It's done for you. So that's a nice feature as well. So when we look at applying these and we look at simple pump curves, a lot of VFD manufacturers over the years, you get the benefits of the soft starts and stops with the VFD, no doubt. With these units, we can do phase conversion. So we can go from single phase to three phase. If you've got single phase power areas in your communities and you want to put three phase pumps in with more torque, these can absolutely do that. That's been a big part of using VFDs in the wastewater world over the last few years. But one of the things that I want to talk about is VFDs and these units can be grossly misapplied as well. And one of the things that I want to talk about is we all know that we have a total head condition on a pump station, and depending on where that system curve, how big your force main is, how much flow you have, how much static head and loss, C-factor loss that you have in your pipe, in your bends, and your check valves, and all those things in your system determines how that system curve will lay in across that pump curve. And I just want to point out a couple things quickly. Is that if we're going to start a pump, the best efficiency point on this pump right here is around that 80% range. And if you look at these different system curves that lay in there, if we were to apply a simple VFD to this curve right here, number one, we're not in a very good spot of efficiency on that pump selection anyway, are we? If we start to slow that pump down, we're getting further and further and further away from that BEP, or best efficiency point, on that curve like you see there. So when we do a pump selection for you, optimally what we're trying to do is we are trying to find a curve, a system curve that lays in the best spot that it can all the way through that BEP. So when we do a pump selection for you, we're trying to optimize and trying to keep that pump at best efficiency point as much of the runtime as we possibly can. The further that you get away from it, we lose efficiency to the right. The further we get away from it over here on the left, we're working our way away. So that's the key to all this, is maximizing the efficiency of your pump selection and keeping it in what we call the sweet spot of that pump for the longest period possible. And as it's pushing wastewater for you on a day-to-day basis, on standard flows coming into your station, it should be able to do this. Now, I'm sure as operators you're asking the question, wow, if I get a lot of I&I, or I get a high wet weather peak flow, what does this mean? These units will recognize that inflow through the transducer. They will ramp up to full speed and they will run. When it hits a level where it's calling for the second pump or the lag pump, where it's randomized its start, which we're going to talk about, it will actually ramp that one up and it'll run both of them, just like you would in a normal duplex station. So here's some more examples of curves, but here's an example of just on a 20% savings in electrical costs by backing that speed down into the sweet spot of the pump, or if you have a system curve that lays poorly on that pump curve, how you can actually lose savings by applying VFDs improperly. So a VFD necessarily isn't the end-all in saving energy. Again, it's great for starting things up, slowly ramping things up and easing that water hammer issue, but it is possible to lose money with them too if they're misapplied. So something to keep in mind. So what do? Is we're monitoring specific energy the entire time on that station, and there is a point as you slow a pump down, and you slow it down 1 hertz at a time over time, what's going to happen is you're going to get to a point where right here, just less than 50 hertz in this particular system, it finds this sweet spot in this specific energy curve. The minute that that unit recognizes that if we get to the left and we slow it down some more and we start to rise in specific energy usage, it will correct and it comes back down into that sweet spot and it settles in on the best spot on that curve of roughly 48 hertz. And it stays there. So in your normal day-to-day operations, it's going to ramp up, clean your pipe, slow back down right away to 48 because that's the best spot to save energy on your equipment. This is a good point to make out too, is that when you get too slow, you start to clog and get sedimentation. When you get down to a point in that system curve where you slow down too much, you can lose that scouring velocity. And when you get to the right, over here, you're wasting energy. So all of our on-off stations, where do they run? They run here all the time. We're turning them on and off at 60 hertz all the time. If we were to optimize the energy with these units, bring it down to 48, we're going to have it in that nice spot. Any questions on that? Anyone? Yes?
Do they work with the flush valve attached to them also yet then?
At this point, no. That's a good point. But with the sump cleaning functionality built into them and bringing them down to snore, and that's a good point because these units are smart units where they're recognizing your flows and they recognize your incoming flow and they recognize if you do have a peak wet weather event that it's gonna ramp up and run at a higher speed and then it's gonna adjust back down. So when you put a mixed flush valve on there right now on one of the pumps, that differentiates the pumps right now. But they're working on building that functionality into it, so right now, no. That's a good question. Okay, so this is a little bit of an animation tool that we have here to kind of show some of these functions. And it really kind of shows some of the things that we've talked about. But I just want to show, for instance, as operators, what an extreme flow inflow situation would look like as this is animated. As that level is coming up, pump 1's called to run. It hits a level. Pump 2 is called to run, just like in a normal type alternation station. But that point, those rings that you see there, the blue and the yellow, that I want to point out here, is that these units randomize their start. And it's all done within about 9 inches of each other. And the advantage of that is for all of you that have grease buildup in your stations, you get a grease ring in your station because that start point is always the same, isn't it? Typically, if you have a float or if you have a start point set on a transducer, that ring ends up in the same place. But when we look at this, with each controller operating independently of one another, we've got about an 8-inch area where every day, at your discretion, if it's midnight on every day, those units are going to randomize those starts. And I kind of compare it to flipping a coin. If you were going to sit there and flip a coin, you got about a 50-50 shot of that thing starting up, right? So we're used to lead pump start, then we alternate, go to the lag pump is then the lead pump on the next cycle. Well, erase that out of your mind, because now what happens is we start that pump independently, and it is possible for pump run 1 to get more cycles in a day than pump 2. But you have to know that with odds and randomization and that flipping a coin concept, that over time, that it's going to be about 50% of the time that these things are going to start and be that lead pump. So what happens in that 8-inch span is every day at midnight, let's say you set that, it's going to randomize its start in that 8-inch spot on that station, and it's going to run down, and that's going to be in that cycle for that time. Then it's going to randomize again 24 hours later, and it might select pump 2, so it might alternate that day, but it could select pump 1 again. But the thing you're getting with that is you're not going to get that grease ring buildup because it randomizes that start within that 8-inch period wherever you set it in your station as a set point. So it's going to randomize, and it redoes it just like you would in flipping a coin with that. So they did a lot of tests with that to see how it would end up, and they did about a 45-day test, and it was uncanny that the pumps really had about the same runtime on them over that period of time. The key to that is it helps keep costs down, keep components less within the panel, and those sorts of things. So it's a little bit, I mean, for me being an operator at one time in my life, it's a lot different than what I was used to, but it's really kind of a unique development in pumping wastewater and helping with energy savings. So the sump cleaning function, pump 1 starts up, pumps it down, brings it down to that snore condition, shuts the pump off. So it helps clean that up. And you can also see right here, this cone-shaped structure right here is what we call our top to bottom, and we also make basins this way. But it's an optimized area that's done flow dynamics on to get the best flow to the pumps that we can get with that shape. So this is slanted. We have slanted base elbows in there, and it drives everything to the suction of the pump to help keep that station clean. And that's the purpose of this bottom in those stations like that. I'm sure as operators you want to know about alarming capability. I said, as simple as it can be, just using those units alone, if we look at this here, these are the alarms that we can pull out of it right away. If you've got a simple duplex neighborhood type station out in your community, you want to save some energy on it, and you put those units in, we can get these alarms. The VFD fault, high level alarm, high motor temp and leakage, right here. Excuse me. Any questions on that at all?
How does that work? Like you put it in a retrofit?
Yeah, we actually did and I'm probably going to show that because I think we'll have time to do it. It's about a 4-minute video. But anytime we do things like this with R&D, we always bring it into the States and we test it somewhere. And we used instead of a county down south in Louisiana, they call them parishes. We used Jefferson Parish, which is just outside New Orleans. It's a very wet area, lots of groundwater. They were having some issues with their pump stations, and we went in, and I really see this as a great retrofit tool. We can go in and put the controllers in, and really what we're seeing is with that 50% savings that we're saving overall, 25% of that 50% savings comes from the end technology in our pump. If you want to save some more, you add the intelligent controller. We're saying 30% of that 50% savings can come from that controller, and then the rest would come from a premium efficiency motor. I think we all have it in our mind that if we put a premium efficiency motor on a specific piece of equipment, that we're going to save a ton of money. But you have to remember, we're pumping wastewater, dirty water here. We're passing materials through it. So with that said, again, a motor savings that you're going to see with the premium efficiency is probably around 3 to 4% more if you're looking at the whole package. But you can get a lot of energy savings with the wet end and the intelligent controller as well. So with that, I think I will. Any other questions? Yes.
How big are these control boxes and how are you mounting them?
Well, they mount on the inner panel or inside the enclosure, inside the inner door. Obviously, the bigger the pump, there's different sizes, but and I don't have it off the top of my head what dimensionally they are, but there's a couple ways you can do it. I mean, you can clean up some components within the control panel and add them in. And you'll see in the video that I'm going to show that's what they did. You can also piggyback a smaller enclosure onto your existing panel if need be to put these units on if you were going to retrofit a pump station. So there's lots of things that could do. An electric pump certainly could help out with kind of planning what would be the best for you if you're looking at a retrofit in your community with something like this. I'll just find this video here. I didn't know if I was going to show it or not. So, but I think it's a good way to end to kind of give you an idea of how this actually works from your perspective.
And several engines over here with on top of the spray whatever. Mechanics. A lot of time and effort. All the projects put that in.
Then said wash out truck and then back up to the street, wash down the area. There's no flow. You see that it's not only a cost, but it's also an appearance that stuff in the street and nobody likes it.
And the three problems will also help back up the that you have.
Our purpose was to try to find equipment that would not only reduce our call outs, but also stay down.
And that's what we designed to do, was speed up the moment and reduce the customer's cost by possibly 20-30%. And the smart controller also has a routine to help clear the pump and conversion.
Display offered to install a motion pumps in more of our lift stations. Got the worst lift stations that we have for closet. And they make that offer we jumped at.
In just days, workers from Jefferson Parish and Gulf States Engineering installed the Light Superior technology pumps and smart run intelligent controls. Installing these was a breeze. You see these two controls right here replace everything here. This is the entire switch now. And you have very continuous controls on the front. Easy to way.
Since we installed the pumps, no call outs. Matter of fact, in our workstation, we used to have to pull the pump once or twice a day. We have not had to pull the pump at all. We have had no clogging.
Pumps are doing a good job. The inspectors come to the regular checkups on it, and if no problem, back up, so I'll stop it. Stop call, installs, operation calls, and cost, not to mention the cost of, we're not very happy with it. So,
We're also realizing a 50% energy reduction, which is amazing. So in the future, we plan to install quite a few more of these pumps, especially on problem areas, and especially on high energy areas. Save a lot more money and prevent a lot of backup that we have on all of that.
Jefferson Parish will be definitely saving a lot of electricity. Anyway,
We believe that what we've seen in this experiment is that we install these pumps, we will save both the call out and the day, that they will pay for themselves within a year, and it's really good investment.
the investment in Light Superior in technology saves money in operations, maintenance, and energy while improving service and sustainability. Light Superior is state-of-the-art wastewater pumping with ultimate reliability, efficiency, and simplicity.
I know that was a little hard to hear, but at least you could all see kind of how a retrofit, because I had the question for it, really was. So with that, I will take any other questions that you have today. Yes, and back? I had a hard time hearing y'all. Come back here. What was that? Yep. Do you have flight pumps now? It depends on the year and the model, but yes, we do have retrofit kits for some, but we would have to get a serial number and do a serial number search, see the bill of materials that they were made with, and then electric pump could definitely look and see if we can do a wet end retrofit for you. But yeah, in a lot of instances we can. What's that? Yeah. Other questions?
Yeah, Pete, how long have you had that in color out? How long you guys?
The Untitled Color's been out since 1999. We have over 300,000 installed in the world and 47,000 installed in the United States. So it's very proven.
How much does the controller box range for just applying them to retrofit it in? As if you're at the flight pump?
I can't answer that right now because it depends on the size of the pump and the size of the drive that you would need. But I would say that
31.7, 10 hours.
4,000 probably. But then you take that and you look at saving on some other components in a panel. So that's a rough guess on a real small pump.
What's the lifespan typically on those controllers? Do you guys have them all long enough to?
Well, they've had them out in Europe for a while, but just like any electronics, it's a similar life cycle cost that you would see on most components in a plant or.
So it'd be pretty similar to the lifespan of VFD.
Absolutely, yep. Yep. Kelly.
Pete, you were mentioning some of the smaller horsepowers and that breakoff points like 7.5 horse from single to three-phase. Does that matter with that controller? Or is it totally like a single-phase controller, or is it like a VFD that's doing some?
Well, we can do phase conversion with it.
With it, okay.
Yes.
Okay.
Just like how normal VFDs are being used now, in a lot of cases, just to do conversion, versus doing some of the other methods that were available on single phase with, eliminating the whole start-run capacitor thing. I think a lot more communities are going to trying to convert that single phase to three-phase type stuff. Yes?
On those two towers, what's the lowest horsepower pump that fit on? Is higher horsepower pump?
We go, with the ends, we go down to our 3085 to our 3 horsepower. Yeah. Mm-hmm. Other questions? One thing that I should also mention that is pretty important with those wet ends is this year, 2013, we have standardized on what we call hard iron is the trademark name, but what it really means is high chrome. So the impeller and the insert ring inside the volute are 25% through and through high chrome throughout. So we get about 10 times the life of those wet ends in areas where we have settleable solids, grit, things of that nature, and that really was developed out of our construction and mining pumps, where we were using them in mines and pumping a lot of gravel and rock and settleable solids and sumps and mines. We kind of brought that over to the part of our wastewater line because, obviously we see that too, and it's even worse on the coast. When we get around oceans, Florida, California, things of that nature in our nation, we get a lot more settleable solids than we even do here in the Midwest. So we standardized on that with all our product this year. Any other questions? Well, that looks like it. Well, thanks for your time today. I appreciate it.